Welcome to ST.SEBASTIAN Pre-University College. Namaste student. Today in this video I am going to explain spectrum. What is spectrum? Now in this picture you can see the rainbow. Okay, rainbow is the best example for the spectrum. Now what is spectrum? When ray of white light is passed through a prism, it spreads out into a series of colored bands are called a spectrum. Now here you can see the picture. Now when white light is passed through a prism, this light spreads into different colors. This spreading is called as a dispersion. Okay. Now these light will appear on the screen. These lights or these colored lights will appear on the screen. These bands or pattern are called as a spectrum. So what is the meaning of spectrum? Spectrum is formed due to the dispersion of white light. Spectrum is formed due to the dispersion of white light. Now next one. See here. Vibgyor. I think you heard already Vibgyor. Now in Vibgyor you can see the different colors. Violet, indigo, blue, green, yellow, orange and red. Now this is a continuous spectrum. This is a continuous spectrum. Now see in the rainbow. See in the rainbow, is there any gap between the colors? You can't see any gap. Each color is merged with the another color. One color is merged with the another color. So there is no gap. There is no gap between one color and with the another color. So that's why it is called as a continuous spectrum. It is called as a continuous spectrum. Okay. So here, spectrum, it has two types: continuous spectrum and non-continuous spectrum. Now here you can see the picture of a continuous spectrum. Okay, so here there is no gap between the colors. Okay, here you can see purple color is merged with the blue color. Okay, and this blue color is merged with the one more color. Okay, and then here also you can see yellow color is merged with the red color. So there is no gap between the colors. So that's why it is called as a continuous spectrum. Okay, but in the case of a discrete spectrum or non-continuous spectrum, okay, here you can see the specific lines. That is a red color you can see, blue color, okay, purple color. You can watch it properly. So in a spectrum, there are two types of spectrum: continuous spectrum and a non-continuous spectrum. Okay, I hope you understood the meaning of a spectrum. Now next one, see, when you heat the substance or any chemical, that chemical also, okay, chemical means it contains of course atoms. This atom also pass radiation, okay, emit radiation. These emitted radiation, if we pass through the prism, okay, that the dispersion of radiation will take place and it will give a band of colors on the screen. Band of colors on the screen. You can watch it properly here. Okay, so this is a one more example for spectrum. Now here spectrum also there are different types of spectrum again, that is emission spectrum and absorption spectrum. Now, what is the meaning of absorption spectrum? First, before what I told, what is the meaning of spectrum? How spectrum is produced? That is, when white light is passed, I will repeat it again. See here, you can see properly. When white light is passed through a prism, that light spread or a dispersion of light takes place, and a color or a Vibgyor is formed on the screen. Vibgyor is formed on the screen. Okay, this is a method of forming the spectrum. Okay, now what is the meaning of emission spectrum and absorption spectrum? Now here it is. Now in the case of emission spectrum, first I will explain absorption spectrum. Now here on the way of white light, if you keep the gas, okay, here it is kept. Now see here, you can watch it properly. That is, a bottle contains gas particles, and white light is passed through a gas particles. Then that white light is then it is passed through a prism. Okay, it will give a spectrum. Okay, that spectrum is called as a absorption spectrum. Okay, that is, I will repeat it again. What is the meaning of absorption spectrum? White light is passed through a gas particles. Okay, then that light is passed through a prism. So dispersion of light takes place. Okay, then that color is formed on the screen. Now that color, band of color, is called as a spectrum. Okay, now here how it looks. Now it consists of dark lines. It consists of dark lines on a bright background. It consists of dark lines. Here you can watch it. That is black lines, you can watch it here. Okay. Now here dark lines on a bright background. Dark lines on a bright background. Now here what happened? This dark lines are absorbs the certain frequency of the color. Okay, it absorbs the frequency of the color. Okay, so that's why black colored lines you can watch. Okay, so this is called as a absorption spectrum. Now next one, it is a emission spectrum. Now here what we should do, directly heat the gas particles. Directly heat the gas particles. We are not passing white light through gas particles. If we heat the gas particles, these gas particles will emit radiation. Okay, that emitted radiations, if we pass through the prism, it will give a pattern of color. Okay, it gives the pattern of color. Now here you can observe this pattern. Now in this bright lines, in this spectrum, bright lines are formed on a dark background. Bright lines are formed on a dark background. Now you can observe properly. Here it is. Here you can watch it. Okay, bright lines. It is a bright line. So you can clearly observe the bright lines on the dark background. Okay, now so what is the difference between emission spectrum and absorption spectrum? In the case of absorption spectrum, what we are doing, we are passing the white light, any white light, to the gas particles which is taken in a bottle. Okay, and then that light is passed through a prism, Okay, dispersion of light takes place and a spectrum is appeared on the screen. Spectrum is appeared on the screen. How it looks, these spectrum. Now here what happened, this spectrum contains dark lines. This spectrum contains dark black lines, dark lines on a bright background, okay. In the case of emission spectrum, directly we are heating the gas particles. So these gas particles, while heating the gas particles, these gas particles will emit radiations. Okay, then that emitted radiations, when we pass through a prism, this will give a pattern of color. Okay, so this spectrum consists bright lines on a dark background. This spectrum consists bright lines on a dark background. Okay, so there are two types of spectrum: emission spectrum and absorption spectrum. Okay, now based on the spectral lines, spectra can be classified into two types. Again, based on the spectral lines, that is line spectrum or atomic spectrum, or we can call it as a discontinuous spectrum. Another one is a band spectrum. First one is a line spectrum. Okay. Then second one is a band spectrum. Now, what is the meaning of line spectrum? What I explained as the emission spectrum and absorption spectrum. These emission and absorption spectrum shows the line spectrum. Okay, shows the line spectrum. Now here usually we are using it explains the characteristic of atom. Line spectrum, it explains the characteristic of a atom. Okay, it consists of distinct lines. Okay, now what is the meaning of band spectrum? Second one is a band spectrum. Band spectrum is formed due to the heating of molecules. Okay, it is a characteristic of molecules. Now here you can see the picture of bands. It consists of closely spaced lines called bands. You can see the bands. Okay, closely spaced lines. I hope you understood the concept of a spectrum. Now we'll move on to the next topic as wave nature of electromagnetic radiations. Now what is the meaning of electromagnetic radiations? Now what is the source of electromagnetic radiations? Of course, sun is a source of electromagnetic radiations. Now electromagnetic radiations includes gamma rays, X-rays, UV rays, visible rays, IR rays, microwaves, radio waves, etc. Okay. Now here you can see the picture of the electromagnetic radiations. Here, this is a picture of electromagnetic radiations. Now, here radiations are associated with the electric and magnetic field acting perpendicular to each other. Okay, both are perpendicular to the direction of their propagation. Here you can see wave is perpendicular to the electric field like this. And even wave is perpendicular to the magnetic field also. Okay, and it is also perpendicular to the propagation. Propagation means it is continuously moving like this. It is moving this way. That is called as a propagation. Okay. Now, what is the meaning of electromagnetic spectrum? I already told. What is electromagnetic radiations? It is nothing but a combinations of gamma rays, X-rays, UV rays, IR rays, microwaves, radio waves. All these are called as electromagnetic radiations. Now what is the meaning of electromagnetic spectrum? Now here these radiations, that means electromagnetic radiations, are arranged in the order of increasing wavelength, or decreasing frequency. I will explain what is the meaning of wavelength and frequency in the next part. Now, what is the meaning of electromagnetic spectrum? It is nothing but a arrangement of electromagnetic radiations. It is arranged. In what way these electromagnetic radiations are arranged? It is arranged in the order of increasing wavelength or in the decreasing frequency. Okay. See here, you can watch it properly. You can see there are microwaves are present, radio waves are there, ultraviolet rays you can see, X-rays, okay, gamma rays you can see, and then there is a visible rays. Now here visible rays means we can see the radiations visible in the visible region. We can see the radiations, okay, but in the case of X-rays we can't see, it is invisible. Even radio waves also, it is invisible, we can't see. So wavelength of visible radiations lie between the limits of 380 nanometer and 760 nanometer. Now here see the arrangement, okay, based on the wavelength, how it is arranged. That is a radio waves, microwaves, infrared, then visible we can see the visible region properly, okay, ultraviolet, X-rays and gamma rays. So this is the arrangement of electromagnetic radiations based on increasing wavelength or decreasing frequency, or I can say increasing frequency or decreasing wavelength. Now here electromagnetic radiations, it move in the form of waves. You already watched this, okay. Now here electromagnetic radiations are move in the pattern of waves, okay. Now, so what are the fundamental characteristic of wave? What are the fundamental characteristic of wave? That means what are the main terms which explains the properties of wave? What is the main terms? What are the main terms which explains the properties of wave? Now here, first one is a wavelength. Now in this, you can see the wave, okay. Now what is the meaning of wavelength? Wavelength means it is nothing but a distance between, okay, distance between. Now these are called as a crest, these are called as a trough, obbu matte taggu, okay. Now wavelength means it is nothing but a distance between two consecutive crest or two successive crest, or distance between two successive trough. I hope you understood, okay. So wavelength means it is nothing but a distance between two crest or distance between two trough. So this is called as a wavelength. So wavelength, it is denoted by Greek letter called as a lambda. This is lambda, okay. Unit is, it is expressed in nanometer. It is expressed in nanometer and it is written as nm. Next fundamental characteristic of wave is velocity, okay. Velocity means it is nothing but a distance traveled by wave in 1 second. Distance traveled by wave in 1 second. 1 ಸೆಕೆಂಡಲ್ಲಿ ವೇವ್ ಎಷ್ಟು ದೂರ ಕ್ರಮಿಸಿದೆ, that is called as a velocity. It is a distance traveled by wave in 1 second, okay. So the value c is equal to, c means it is a speed of light, okay. So this speed is also equal to velocity of electromagnetic radiations, that is given as 3 into 10 to the power 8 meter per second. Now third characteristic is a frequency. Frequency means it is nothing but a number of waves which pass a given point in 1 second. Number of waves which pass a given point in 1 second. Okay, now here you can see this frequency. Now in 1 second, you can watch it properly. In 1 second, okay, how many waves passes? How many waves passes? Now, one wave means this much is a one wave. Okay, now imagine that this is a given point. Okay, in 1 second, how many waves are passed? That is 1, then 2, 3, okay, 4. So 4 waves are passed. So number of frequencies is 4, like that. Now it is what is the meaning of frequency? Frequency means it is nothing but a number of waves passed through a given point in 1 second. Passed through a given point in 1 second. Okay. Now here you can watch it. This is a low frequency. Okay, this is a low frequency. This is a low frequency. That means less number of waves are present. Now here in the second, this is a high frequency. More number of crest and trough, you can watch it. More number of trough and crest. Okay, more number of waves are present here. So this is a high frequency. So what is the meaning of frequency? It is nothing but a number of waves which pass a given point in 1 second. So it is unities, it is a second inverse, or it is a hertz. Now these three fundamental properties of wave are interrelated. That is, velocity, frequency and wavelength are related by the equation, that is C is equal to nu lambda. C is equal to nu lambda. Nu means it is nothing but a frequency. Pronunciation is a nu. C is equal to nu lambda. Okay. Now one more characteristic of wave is wave number. It is a wave number. Wave number means it is nothing but a number of wavelengths in 1 unit length. In 1 unit length. That means in 1 centimeter, how many wavelengths are present, or in 1 meter how many wavelengths are present. So that is called as a wave number. Number of wavelength in a unit length. It is nothing but a reciprocal of a wavelength. It is nothing but a reciprocal of a wavelength. So it is written as nu bar. So it is written as a nu bar is equal to 1 by lambda. Okay. So it is expressed in centimeter inverse or a meter inverse. Line spectrum of hydrogen. Now spectrum definition I already explained. Okay. Spectrum means it is nothing but a dispersion of white light on the screen. Dispersion of white light on the screen. Okay. Now most of the emission and absorption spectrum are a line spectrum. Okay. Now here line spectrum of hydrogen. Now how it is done? In this, hydrogen gas is heated. Hydrogen gas is heated. Okay. So during that time what happens? Electron which is present in a hydrogen, it start jumping from one level to another level. One level to another level. Okay. Now here, so electron, imagine that hydrogen, it is heated. Okay. So what happened? Electrons starts jumping from one level to another level. Okay, now in the higher level it is highly unstable. Electron in the higher level, it is highly unstable, and it will come back. Okay, while jumping from lower level to higher level, it absorbs energy. It absorbs energy in the form of photon. Okay, and as I told that at higher level these electrons are highly unstable. So what it will do, it will come back to their original level. It will come back to their original level. So while coming back, it will emit radiations. It will emit radiations. Okay, then these emitted radiations pass through the prism. This will produce a spectrum. I hope you understood. Okay, so hydrogen gas is heated. While heating, electron jumps from one level to another level. Okay, so while moving from lower level to higher level, what it will do, it will absorb energy from the heat and it will jump to higher level. There it is highly unstable. So what it will do, it will return back to their original level, that is a lower level. Okay, while coming back, what happened, it will emit radiations in the form of energy. It will emit radiations in the form of energy. These emitted radiations, if you pass through the prism, what happened, dispersion of radiation takes place and spectrum will appear on the screen. Okay, so different spectrums are formed, and these spectrum were observed by different scientists. Different spectrum were formed. So these spectrum are observed by different scientists. So that is Lyman series. Lyman's scientist called as a Lyman. He observed hydrogen spectrum. That means he observed closely spaced lines. Okay, under UV region. So that series are called as a Lyman series. And same thing, Balmer, scientist called as a Balmer, he observed hydrogen spectrum under visible region. Visible region means we can see the colored lines. Okay, so that series of lines are called as a Balmer series, and Balmer scientist called as a Bastian series. Even he observed hydrogen spectrum under IR region. So these series of lines are called as a Bastian series because observed by scientists called as a Bastian. Same thing, it is a bracket series and a fund series. Okay, now here you can see the picture. Okay, hydrogen gas. While heating the hydrogen gas, it emits radiation, and then emitted radiation, when it is passed through the prism, it will gives a spectrum. Okay, now the first scientist called as a Balmer. Actually, scientist Balmer, he observed a first spectrum. He observed a first hydrogen spectrum. He observed under a visible region. That means we can see properly. We can see the colored lines. So here you can watch it, red lines, blue lines, dark blue lines. So this is observed by Balmer series. Okay, next Lyman series, he did same experiment. Okay, but he observed the spectrum under a UV region. So that is called as a Lyman series. Okay, and then remaining Bastian series, these bracket series and fund series are observed in IR region. Okay, IR region. So it has a different wavelengths. Now see here. Now in this you can see the lines. Now scientist, that is a Balmer, okay, Balmer, he calculated a wavelength of a lines, spectral lines. He calculated wavelength of a spectral lines, each lines, okay. Now he derived one formula, that is this: 1 by lambda is equal to 109,677, or you can write 1.09677 into 10 to the power 7. That also you can write 1 by 2 square minus 1 by n2 square. Okay. Now that is, he derived one formula to calculate a wavelength of a spectral line which is observed by Balmer. Okay. After that, one more scientist called as a Rydberg. He formulated equation, a general equation to calculate spectral lines of any series. Okay, Rydberg, scientist name called as Rydberg, he formulated one equation to calculate spectral lines of any series. Okay, spectral lines of any series by using this formula, that is 1 by lambda is equal to 1 by lambda is also called as a wave number. I already told that wave number, it is nothing but a reciprocal of a wavelength. Okay, so 1 by lambda is equal to R into 1 by n1 square minus 1 by n2 square. Now here n1 is fixed. n1 is fixed for a different series, that is n1 is equal to 1 means it is nothing but a Lyman series. n1 is equal to 2 means it is a Balmer series. n1 is equal to 3 means it is a Paschen series. n1 is equal to 4 means it is a bracket series, and n1 is equal to 5 means it is a fund series. Okay. Now what is a n2? What is a n2 value? Now suppose n1 is equal to 1, that is what I told, this is for a Lyman series. So n2 becomes, it is greater than n1. Okay, greater than n1, that is 2, 3, 4, 5, like that it will go. Same thing, n1 is equal to 2 means it is nothing but a Balmer series. Okay, so n2 is equal to, it is greater than n1. So greater than n1 means what is the next number of 2? That is 3, 4, 5, 6, like that I should write. So same way, that is for a Paschen series. For Paschen series n1 is equal to 3. Okay, so n2 it becomes 4, 5, 6, 7, it will go like this. Okay, I hope you understood this concept. Now here it is written, so Lyman series n1 is equal to 1, so n2 it becomes 2, 3, 4. Lyman series are observed in ultraviolet UV region. Okay, Balmer series n1 is equal to 2, so n2 it becomes 3, 4, 5. So it is seen under visible region. Paschen series n1 is equal to 3 and n2 becomes 4, 5, 6, and it is seen under infrared region. Same way bracket and fund series also it is observed under spectra, under infrared region or IR region. Okay. The calculation I will explain later with the help of Rydberg equation. Here you can watch it. Okay, now this is a emission spectrum of hydrogen. Emission spectrum of hydrogen. Now absorption spectrum means it is jumping from, while heating the hydrogen contains only one electron. Okay, that electron starts jumping from one level to another level. Okay, this is called as a absorption because while jumping from lower level to higher level, what happened, electron takes energy from the heat and it will jump to higher level. Okay, jump to higher level, but there it is highly unstable. Electron is highly unstable. So what it will do, it will come back. It will come back to its original position. It will come back to its original position. So during that time, what happened? Emission takes place. Okay, emission of energy takes place. Okay, now so this is shown here, that is a emission spectrum. Okay, emission spectrum in the syllabus only emission spectrum of hydrogen is given. Absorption spectrum is not, it is not included. Okay, now so this is a emission spectrum of hydrogen. Now here what happened, electron jump from higher level to, that is higher level to number 1. So n is equal to, this is n1 is equal to 1, this is a n1 is equal to, n1 is equal to 3, n1 is equal to 4, n1 is equal to 5, like that. Okay, electron jump from higher second level to first level, higher third level to first level, higher fourth level to first level, and higher fifth level to first level. So since n1 is equal to 1, which series? This is called as a Lyman series. Okay, this is called as a Lyman series. Same way, if electron jump from third to second, fourth to second, fifth to second, n1 is equal to 2 means it is nothing but a Balmer series. In the Paschen series, what happened? Electron will jump from fourth to third, fifth to third, sixth to third. Okay, so since n1 is equal to 3, this is a Paschen series. Same way, bracket series, it will jump from fifth to fourth, sixth to fourth, seventh to fourth. Okay. So this is called as a bracket series, and in the case of fund series, it is from 6th to 5th, 7th to 5th. Okay, and then with the help of Rydberg equation, we can calculate wavelength of each spectral lines. Wavelength of each spectral lines. Next topic is photoelectric effect. Now, what is the meaning of photoelectric effect? Now, here, photoelectric effect means when light incident on the metal. When light incident on the metal, what happened? Incident means hitting of light, or light will fall. When light falls on the metal, this metal eject electrons or emit electrons. So this phenomenon is called as a photoelectric effect. I will repeat it again. When light falls on the metal surface, this metal eject or emit electrons. So this phenomenon is called as a photoelectric effect. Planck's quantum theory of radiation. Now, what is the meaning of Planck's quantum theory of radiation. This theory proposed by Max Planck in 1900. Okay, what he explains the black body radiations. Anyway, this black body radiation you are going to study in physics. Okay, now here Planck's quantum theory of radiation, it is also called as a black body radiations. Now, what are the postulates of Planck's quantum theory of radiations? According to his point of view, electromagnetic radiations are emitted, absorbed and propagated. It will emit, absorbs and propagated. Propagated means it is moving continuously. Okay, moving discontinuously in the form of a small packet of energy. Now here, before discovery of Planck's quantum theory of radiation, the other scientists, they were imagine that electromagnetic radiations are propagated continuously. Okay, like this, are continuously. But Planck explained that it is propagated discontinuously. It is propagated discontinuously in the form of small packets like this, tiny packets. It is discontinued in the form of tiny packets. Okay, so these tiny packets or each packets of energy is called as a quantum. Each packets are called as a quantum or called as a photon or called as a photon. Okay, now here each quantum or each packet is quantized. Each packet, second postulate, each packets are quantized. What is the meaning of quantized? Quantized means it has a fixed amount of energy. Each packet has a fixed amount of energy, that is E is equal to h nu. E is equal to h nu. Okay, and then a body emits or absorbs radiations only in integral multiple of the quantum. That is, here what I told at the beginning, electromagnetic radiations are emitted, absorbed and it is propagated. It moves continuously. Okay, but it is not continuously. It is in the form of a discontinuous. That is like this, small packets. Okay, it is in the small packet of energy. It moves in the small packet of energy. These packet of energy are called as a photon. Okay, now this packet of energy are quantized. Quantized means it has a fixed amount of energy, that is in the form of E is equal to h nu. E is equal to h nu. H is a Planck's constant. Okay, now here this E value, each packet of energy are in the form of 1 into h nu E is equal to 1 into h nu. E is equal to 2 h nu. E is equal to 3 h nu. That means energy are in the form of a integral multiple of the quantum or a whole number. Okay, E energy will never get in the form of 1.5 h nu or E is equal to 2.5 h nu. You will never get E is equal to 1 fraction. Okay, so that means E value in the form of energy value, it is in the form of a integral multiple of a quantum. So this is about Planck's quantum theory of radiations. I hope you understood this concept. Thank you.